Here's a rational equation which involves only letters. That makes it a literal equation. And it's kind of similar to one I worked out in my book that I wrote, but it's a little more complicated. And it is an equation from, or a formula from statistics. So it reads, solve for mu, and this letter is the Greek letter mu, mu. Solve for mu. Z equals to the square root of n, parentheses, x bar minus mu, divided by s. So this is related to the bell curve in statistics. And if you really want to know, n is the size of a sample, s is the standard deviation of the sample, x bar is the average or mean of the sample, and mu is the population mean. So anyway, let's solve for mu, and I need to clear everything away from mu. So what's in its way? Well, the easiest thing to get rid of, I believe, would be the square root of n and s, because in a sense these are multiplying the right side. So I want to clear this away, and this will give us only x bar minus mu. So I'm going to multiply both sides by s divided by the square root of n. And as you can see, the s cancels, and the square root of n cancels. Numerators cancel denominators. And so I have on the left side, I have s times z over square root of n. So this is s z divided by square root of n equals to, and what's left on the right side is x bar minus mu. Alright, so we're almost done solving for mu. I'm going to subtract x bar off from both sides. So I have sz divided by the square root of n minus x bar equals to negative mu. So I subtracted x bar from both sides. I canceled it on the right side and left negative x on the left. At this point, to solve for positive mu, I've got to change the sign. I need to multiply by negative 1. So I'm going to multiply the entire equation by negative 1. Well, that has the effect of reversing the subtraction, because this becomes negative, this term becomes positive, and that becomes positive. So here I've got positive mu is equal to, and I'll reverse these, x bar minus sz divided by the square root of n. Alright, so there's our answer. Now, one thing I want you to notice about all this is that I treated all the letters in this equation like numbers, because they represent real numbers, and so they work like real numbers. You know, I multiplied it and divided, I subtracted, multiplied again, and so it's really no different from solving an ordinary equation, except that you don't get to combine numbers together in this problem. You know, we can't say add 2 plus 7 and get 9. We can't squeeze numbers together. Since every letter is different, nothing will combine together. Beyond that, it solves like any other equation. So don't be intimidated by these. They're just ordinary equations with a bunch of letters in them.